Alright, a piecewise continuity problem. We want this function to be continuous, so that tells me at each of these points that we're interested in, -1 and then also +2. We need to look at those two functions together, and we need to make sure that they have the same value when x equals -1, and then make sure the bottom two have the same value when x equals +2. So we are going to create a little system of equations, but really we'll just use some substitution to solve it. So let's take our first two in red. We are going to take that top equation, 2x squared plus k, and we're going to substitute in at -1 to get 2 times -1 squared plus k, and we're going to set that equal to the middle equation, 3j plus x, but x is -1. So if I simplify this, I'm going to get 2 plus k equals 3j minus 1. Let's go ahead and solve this for one of my variables. I'm just going to go ahead and solve it for k to get k equals 3j minus 3. Now let's do the same thing with my blue equations. So I'm going to get 3j plus 2 equals 4k times 2 plus 19. Let's simplify a little bit. Notice this. I'm actually going to change something over here. I am recognizing that I have a 3j right there. So I'm going to say that k plus 3 equals 3j. And I'm going to go ahead and just substitute 3j in. So I make this equation k plus 3 plus 2 equals 4. Let's go ahead and do 4 times 2 is 8k plus 19. Let's simplify it a little more. 3 plus 2 is 5. Let's subtract that 5. And we will get k equals 8k plus 14 when we subtract 5. So -14 equals 7k, and k equals -2. Whoa. So now let's go ahead and take that equation there and rewrite it as k over 3 plus 1 equals j by dividing 3 on both sides. And now I'm going to substitute in my k value to get -2 thirds plus 1 equals j. So 1 minus 2 thirds is 1 third, and I have my j value as well. And you should be able to plug those back in, j and k, and evaluate those values of x, so -1 and 2, and find that you are continuous.